In this video, we introduce a Corticon feature called server-level thread pooling. This feature allows the server to determine how many concurrent requests are to be processed at any one time, giving you greater control over your available resources. We begin with a review of 5.4, where the recommendation was to set the min-max pools for a decision service equal to the number of cores on your system. This worked well with a single decision service deployed on that server. Problems could occur when multiple decision services were located on a single server. If each of the decision services has a min-max value equal to 4, the potential load on that machine could be 16 threads attempting to execute at the same time. This might cause the server to be overwhelmed with requests, which requires thread swapping by the server, and ultimately results in poor performance in your system. In 5.5, we improved thread pooling by replacing decision service thread pooling with a single server-level thread pool. All decision services requests are placed in a first-in, first-out queue. The number of concurrent threads is set at the server level, defaulting to the number of cores, represented by the orange boxes on the server. Instead of 3 separate queues hitting the server simultaneously, all requests wait in a single queue, so requests never exceed the available processors. As each thread is processed, it stays in the queue, and when the thread is complete, it is removed from the queue, and the next thread in the queue begins processing. In this example, that would be B2. In Corticon 5.5, we introduce the server property shown here. Setting this in the brms.properties file, you can clearly state your intentions for the number of concurrent executions. If you leave the default of 0, then it sets the property to the number of cores. This is the recommended setting. Whenever we make recommendations, the next question is typically, when would you want to change this value? If you want to reserve resources for other processing, you can opt to set this value lower, as the diagram shows, setting the value to 3. If you know that your decision services requires fewer resources, you might decide to set this value higher, as shown here. For the rest of this presentation, we'll leave the default of 0 and assume a 4-core server. Now that the decision services threads must wait in the queue, you might want to prevent the threads sitting in the execution queue for too long. A new timeout property shown here prevents the thread from sitting in the execution queue for too long. Once the thread is added to the execution queue, it will have a finite amount of time to complete its execution. Notice the stopwatch at the queue level. If the thread fails to complete its execution in time, a CC server timeout exception will be thrown. The default value is 3 minutes. The timeout period is configurable, but you need to factor in the execution time, not just the wait time, when changing this value. Server-level thread pooling will occur automatically for 100% of our customers in Corticon 5.5. For 90% of those customers, no additional configuration will be needed. We estimate that less than 10% may want additional control over the queue. That control is called allocation control. It is the ability to allocate more resources to a specific decision service. For example, you may want to have a particular decision service to process 3 times as many requests to process new orders than other decision services that process requests for general information. This gives more of your resources to processing orders than requests for general information. To control allocation on the server, you need to set the max pool size for each decision service and enable allocation on the server through a new property. This property tells the server to factor the max pool size of each decision service into how it fills the queue. As a developer, you would want to set appropriate max pool size values for each decision service when you deploy it to your server. So if A represents new orders, and B and C are information services, by setting max pool sizes for the decision services to be 3:1:1 respectively, the server will maintain a 3:1:1 ratio for requests getting added to the execution queue. There are 2 ways to change the max pool size for a decision service. and they are dependent on how you deployed your decision service. If you use iccserver.addDecisionService to deploy, set it using the parameter AI max pool size and update with the modified decision service pool sizes. If you use CDD files, set it by changing the max size in your CDD file, or change it in the CDD file and allow the CC server maintenance thread to detect the change. It is important to note that using allocations is a two-step process. If you do not enable allocations, these properties are ignored. To use the new allocation, you must set the com.corticon.server.decisionservice.allocation.enable to true. By default, it is false or off. Setting this property to true will use max pool size, which is set when you deployed each decision service to cap the length of the execution queue to the sum of the max pool size values. In this example, that sum is 5. By giving decision service A the max pool size of 3, you are giving one decision service a higher ratio of service. This is not a priority. It is just a change in the ratio in the queue. Now that you have effectively set the limit on the server-level thread pooling queue, you might consider how long is too long to wait just to get in line. Unlike the previous timeout, this one is just waiting to get into the queue. Using this setting provides developers with control over how long to wait. If the wait time exceeds your limit, an exception is thrown, allowing you to handle the exception rather than waiting indefinitely. This exception will be a CC server timeout exception. These enhancements have resulted in the deprecation and removal of a few properties. The min pool size is deprecated and no longer relevant. The max pool size has a new usage, but only when combined with allocation being set to true. Lastly, the following properties associated with decision-level thread pooling have been removed. In summary, all customers will benefit from the new server-level thread pooling. For those that want more control, we reviewed the necessary properties that have been added to provide control. Additionally, in Corticon, several properties have been redefined, deprecated, or removed